part of the lesson, we're going to talk about how to solve a system by graphing. And we can do it by hand like you guys did in Algebra 1, but I'm going to show you how to do it on a calculator. So you could have this TI-84 plus CE, or just a regular TI-84 or TI-84 plus, or the TI-83 will work. So it'll be a similar process for all of these. And I'm going to use my 84 because it has the least amount of glare on the screen. Okay. All right, so when we are solving by graphing, whether it's by hand or on the calculator, our equations need to be in the form of y equals. So if they wouldn't be in that form, then the first thing that we would have to do is solve each of the equations for y. Okay. So the first system, we're okay. So I'm going to grab my calculator. And I'm going to zoom out here so you can see the buttons I am pressing. So I just press the on button down here. And then anytime I want to graph, we're going to go into this y equals up here. Okay. Now you shouldn't have anything in there, but if you do, you're just going to press the clear button. We also want to double check to make sure that these up here are not highlighted. So for example, if it looked like this, we would need to deselect that by just arrowing up and then pressing enter and then arrowing back down to deselect it. So we want a completely blank screen with nothing highlighted. Now if you do notice that there's some weird things going on, like symbols over here that you just can't quite figure out how to change, what you want to do is just reset your calculator. So if we were going to reset the calculator, we are just going to press second and then the plus key. And that will bring us into the memory. And then we're going to arrow down, or you can press the 7 key to select reset. And then we want to do all RAM, so we're going to press enter, and then arrow down or press the 2 key, and then reset it. And then that's going to bring your calculator back to all the default settings and clear everything out of anything you might have been using. So again, if you're having issues, try resetting your calculator and then going back in and working through your process. All right, so again, to graph, we're going to press y equals, and then we are going to type in the equation except for this y part. So we're going to type in 3x plus 5. So I'll use my 3 key, and then the xt theta n gives me the x, and then plus 5, and we press enter to go down to the next line, and now I'm going to type this one in. So anytime we have a negative number, we need to use the negative key at the bottom of the calculator and not the subtraction key. So if you use your subtraction key, you're going to get an error message. And then we can put this fraction in parentheses, so 1 divided by 3. And then we have our x key, and then plus 2. Excuse me. So now that we have our equations typed in, I don't remember what my window is, so I'm going to go up here to this zoom key in the middle, and then I'm going to go down to where it says standard. So this is always a good starting point when we graph because it's going to automatically put your window into a -10 to +10 for both the x and the y. And we should see 2 lines. All right, perfect. So I know that this system has a solution. If we were asked to classify, we would say that it's consistent independent because there's one intersection point. And now we're going to find this intersection point. So to do that, I'm going to go up into this calc menu. So it's above the trace key. So anytime you're trying to get to something above your key, if it's blue, we're going to use the second button. Whereas if you notice some of these letterings are green, if we need one of the green keys, we would press alpha. But since calc is in blue, I'm going to press second and then the key, so trace. And then we're just going to look at our options. So we are trying to find the intersection point. So I'm going to go down to number 5 where it says intersect. So I can either arrow down and press enter, or I can just press the 5 key. Okay. And then our calculator is going to ask us 3 questions. It's going to ask us for the first curve, the second curve, and then a guess. So when we're trying to find the intersection, we just want this cursor to be close to the intersection as possible. So if you arrow to the left and to the right, that will move that cursor to where you want it. Now if you happen to go up and down, so I want you to pay attention to this piece, if we go up and down, that changes the line that it's on. So make sure that you're going left and right to move the cursor instead of up and down. So I want this to say y1, and then I'm going to press enter. And then now it's asking for the second curve, and this changed to that second equation, which is what we want it to happen. And it's still close enough to that intersection point, so I'm going to press enter. And then anytime we see guess, we're just going to press enter. Okay. So our intersection for this is going to be at -0.9. I'm going to write this as a point, so -0.9, comma 2.3. And then at that point, if we're ready for our next one, we would just go back into the y equals. We're going to clear what's there, and you just use your arrows to move up and down. And then we're ready to start with our second equation. Now remember, these have to be in the form of y equals. So I have to solve both of these equations for y before I'm ready to type them in. So that means I'm going to subtract the 3x over, and as I do that, I'm going to divide by the 2. So we are going to graph y equals -3 over 2x plus 5 over 2. And then for this one, I just have to add the 6 over. So y equals 6x plus 9. Okay, so back to my calculator. So again, to get to this screen, we would have just pressed the y equals button up here at the top. And I'm going to arrow back to that first one. So I'm going to type that in. So I'm going to use a parenthesis. It's negative, so I need to use the negative key. So -3 divided by 2 parenthesis, and then the x key. And then we have plus, and then 5 divided by 2. And I don't need a parenthesis on this one because I'm not multiplying it to anything. But if you do put a parenthesis around it, that's completely fine. And then I'm going to press enter to go to the next line. And now I'm typing this in. So 6x plus 9. Now I know that I graphed in a standard window last time. So once you have that window, when you graph it, it's going to stay in that if you just press your graph key. So since I know what my window is, I'm just going to press graph this time. Or you could go back into your zoom key and pick standard. Okay. All right, so again, we have that one intersection point here. So to calculate that, we're going to do second, trace, and then down to number 5 where it says intersect. And then I'm using my left and right arrow keys to move it closer to where those lines are meeting. So anywhere in this area is fine. And then we press enter. And then my cursor stayed there, so I'm just going to press enter again. And then I press enter one more time when it says guess. So I know I'm done when I see the word intersection here. So we are asked to round to the nearest hundredth. So for this problem, our point is -0.87, comma 3.8. And again, if we were classifying, we have a solution, so it's consistent, and we only have one solution, so it is independent. All right, so again, before we can use our calculators to graph, we would need to solve these equations for y. So on this one, I'm going to have to add the 2 and then at the same time divide by 4. So y would be -2 over 4x plus 6 over 4. So if I simplified that, that's going to be -1/2 x plus 3 over 2. And then same thing, I need to solve for the y, so I'm going to add the 3x and then divide everything by 6. So y equals 3 over 6x plus 8 over 6. Oh wait, I was supposed to, add, this should be a positive. And then if I simplify this, this will be y equals 1/2 x plus, and then these are both divisible by 2, so 4/3. Okay. All right, so again, to practice, y equals, I'm going to clear what is there. So I press my y equals, clear what's there. So if I type in this one, so, whoops, wrong spot. So 1 divided by 2, x, plus 3 divided by 2. And then down to here on this one. So 1 divided by 2, x, plus 4 divided by 3. And then I can just press graph because I know what my window is. All right, so it's really hard to see this because do you notice how that line got a lot thicker? So what I'm going to do is I'm going to press the zoom button, and then I'm going to click zoom in. And then I'm going to move my cursor to this spot where I want it to center on. So I'm just going to kind of pick, so if you see my cursor right there, I'm just going to pick a spot on that dark line, and then I'm going to press enter. And it will automatically zoom in for me. Okay, so the reason why I did that is I wanted to make sure that I had 2 separate lines instead of it graphing on itself. So there is definitely a space in there. So these lines are parallel to each other. So my answer to this one would be no solution. Okay. Now I could tell that before graphing. So when you look at this, if you have the same slope and then different y-intercepts, they're never going to intersect because they are going to be parallel. So I would be able to tell that without having to graph it. But if you were looking at your graph, they shouldn't be intersecting. Okay. All right, last example. So again, we have to solve for y. So that means I'm adding the 3x over and then dividing everything by 5. So that will be y equals 3 over 5x plus 7 over 5. And then here I am adding 6 subtracting 6 dividing by negative 10. So y equals negative 6 over negative 10x and then minus 14 over negative 10. So now if I simplify, that will become a positive. Those are both divisible by 2. So this will be 3/5 x. And then a negative divided by a negative is a positive, both divisible by 2, so 7 over 5. Okay. So looking at that, I would have the exact same equation, so I don't need to worry about graphing this one on my calculator, because if we're graphing a line and then the same line on top of it, it's going to be infinitely many equations. And then when we do say infinite, we need to give the equation. Because remember, even though there's an uncountable amount of solutions, all the solutions have to be on this line. So that's why we need to include that as part of our answer when we are saying infinitely many.